Hello friends, welcome to the channel Digital Design Academics to Industry. Playlist is Target Preparations for Exam. This is session number 5. Let us start. We have completed 9's complement subtraction, 10's complement subtractions, binary number system, physical understanding of these binary numbers, binary conversion to decimal conversion, decimal to binary conversion, fractional decimal number to binary number, binary addition, binary substitution, and binary multiplications. Today I will explain the signed numbers in binary number system, 1's complement, 2's complement, and their ranges. And I will also explain the 9's complement gocha, right? I explained that in 9's complement subtraction, I mean to say when I have to do a subtraction in decimal number system, I can use 9's complement or 10's complement. But to achieve a 9's complement and 10's complement, we need a subtraction again, right? To do the subtraction, to receive or generate a subtractor, we need a subtractor, right? So it is not possible. For example, I want to subtract a minus b. We says that we will take 10's complement or 9's complement of b plus a plus b. We will get a result. But to get 9's complement or 10's complement of b itself, we need a subtractor, right? But how we are resolving that condition in binary numbers instead of decimal number, I will explain here. That will be a physical understanding other than just a mathematics. You take one thing, right? In every session, I tell one thing other than mathematics, other than a normal way of teaching, right? I just always want to relate the digital design and the digital basics to a real chip fabrication level, right? With time, I will prepare you people to the level of designing the chips. But every time when I'm trying to give any information, I am trying to correlate it with the physical chips, voltage, current, etc. Let us start. So when I was saying that to generate the subtraction or do the subtraction, we need 9's complement, right? Then only we will do some plus and we will get the 10's complement as a per the previous class, right? In to do the subtraction in binary number system, we first need 1's complement and then we add 1 and we get the 2's complement, right? So, and here let me mark two important things here. When I am in binary number system, binary number means 2, or we can say 0 to 1 means 2. How many digits we can have? 0 to 1. Maximum digit is 1 in one place, or at one location maximum number possible digit is 1 binary. In decimal, I have explained that 9 is the maximum. 0 to 9 are 10 numbers, right? So for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 0 is itself a number which will be counted as a 1, right? So decimal numbers goes from 0 to 9. So to get the ones complement, what we do? For example, we have a 3-bit number. 3 is n is equal to 3. So what is the locations? 0th location, first location, second location, and third location, right? So what we will do, we will make 1, 0, 0. This is 2 raised to power n, right? Means 2 raised to power 3 means 1, 2, 3. This is 2, 4, 8, right? This is 8, 2 raised to power 3 is 8, right? Minus 1 means 1, 1, 1, right? 1, 1, 1, 1. Now I want to find the ones complement of 0, 0, 0. What I will do? Subtract out of that. This is ones complement. Get the maximum number. So you understand by the formula, like examiner can give in this format. So I want to correlate, right? Please be attentive while when I am explaining the concept. Okay. Let me. mm, Sorry guys. Sorry for inconvenience. Okay, let me explain in detail. Okay, because it might be there, that is confusion you will have. Okay, because this is a question which can come in exam. Examiner can ask like in some complex method, right? So let us say when I'm in binary number, the maximum number is 1 if it is single bit. If it in decimal, maximum number is 9, right? So when we are in binary, the maximum number represent the complement of this, right? So binary number is then 1, then we says 1's complement. In decimal number, maximum number is 9, so we call it 9's complement, right? 1 and 9's, because 9 is maximum here. So for example, if there is a number called as 101, right? And I want to calculate the because it is a binary number, I want to calculate the 1's complement. So what I will do, I can simply write 111 minus 101. This is 0, this is 1, 0. Binary subtraction I have explained to you. This is the basic thing. But now, if I want to write in this format, if I want to write in this format, how I can write? So if you say 101, right? This is 0th location, this is first location, this is second location, 3-bit number. So if I will create a third location, right? These are 3-bit number, 3-bit number, right? So if I will do 2 raised to power 3, what is this? That is will be 8. 8 can be represented as like this, right? And if I will write minus 1 out of it, what I can do? Minus 1. What is that? 1, 1, 1, 0. What is this? This. That's how we can write 2 raised to power n. You remember it, 0, 1, 2. But count the numbers, not this bit location. Count the numbers. 1, 2, 3. So this is 3-bit number. So do 2 raised to power 3 minus 1 minus number is the 1's complement. 9's complement, because 9 is the maximum number, right? So assume, let us again, 383 is the maximum decimal, is a decimal number. We have to calculate the 9's complement. What we will do? We have to do subtract 999, 383, 6, 1, 6, right? Now you see that to get a 9, what we can do? Simply what we can do, 10 raised to power 3. What is that 10 raised to power 3? 1000 minus 1. What is that? 999, right? So you understood it, right? That's how we can write it in tabulated form. 10 raised to power 9 minus 1 minus number, 2 raised to power n minus my number. This can be a direct MCQ question in exams. Okay. So now, why I was explaining this? The point of why I was explaining was that I told that if I want to do a minus b, right, in decimal form, I will say that I will take the 9's complement of that. But to do the 9, to find out the 9's complement, I need a subtractor again, minus number, right? So I need a subtractor, and I am doing subtraction for that. So is it a hen come first or a egg come first condition for a digital design level? But how we resolve that issue in binary numbers? In binary number, we subtract this thing like 111, subtract of 101, so 010. So we have to notice one thing, that for example, I want to calculate the 1's complement of this. So what I will do, I will write 111 minus 001, right? What is this? 011. So if we will relate it this one, instead of subtraction, if we will do the NOT gate, these are just inverted values. These are inverted values. This 0 is 1, this 0 is 1, and 1 is 0. So instead of doing the subtraction in binary number system, 1's complement can be done with the help of inverters, right? Without subtraction. That's why digital design works on binary number system, and computers can use 1's complement with help of inverter. Even though we don't have a subtractor, we can do the 1's complement with help of inverter, right? That's why physically 1's complement can be used in the computers, right? Or take it a different way. Somebody tells that, okay, tell me what is the from this concept. If exam, a question comes in exam, what is the ones complement of this? We can say simply invert them. 0, 1, 0. This is the answer. What is the ones complement of 1, 1, 1? Invert them. 0, 0, 0. What is the one complement of 1, 1, 0? Invert them. 0, 0, 1. Right? This is the answer. This is one's complement. Let us go for the two's complement. Two's complement is nothing. Simply do the same. For example, I want to get the ones complement of 0, 0, 1. Invert it, right? Then adder 1 to LSB. There is should be adder circuit which adds 1 to it, right? 1, 1, 1. So what is that two's complement of this? 0, 0, 1 plus invert them 1, 1, 0 plus 1, right? So let us an example of 1, 1, 1. Let us take the two's complement of this. Invert them. Here the output will be, if I will give 1, 1, 1, 1 here, so it will be 0, 0, 0, 0, and then it will LSB will be added with 1. So answer will be 0, 0, 0, 1. Good. This is two's complement. That's simple. Now I want to explain the signed numbers, if the numbers are like positive or negative. Okay. For example, if a number, I am saying that I have 4-bit number, right? For example, there is a 4-bit number. How many? Like 4, third bit, second bit, 1 plus 2, 1, 2, 3, 4. This is 4-bit number, right? So if its all is high, this is 1, this is 2, this is 4, this is 8. So sum is 15. But I want to explain the signed numbers. I want to know that this number is a positive or negative. So what digital electronics do it, that it uses the MSB like 3210. This uses the MSB to denote the sign. For example, if it is 0, then it will be 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3, 0, 0, 0, 4. So this is 0 number. If it is 1, 1, 0, 0, so it is minus 0. If it is 1, 0, 0, 1, this is minus 1. It is 1, 0, 0. So you see, this 1 doesn't comes in the magnitude. Normally what we do, 3, 2, 1, 0. Okay. We write like 1, 0, 0, 1. What do you do? This 1, 2, 4, 8. So what we do, 1 into 8 plus 4 into 0 plus 2 into 0 plus 1 into 1. So it will be 9. But here we don't consider the MSB. For MSB, just we do use to recognize that it is a positive or negative. So to calculate the magnitude, we just use these numbers. MSB, the most significant bit, we leave it for only for the recognition. मतलब हमको पहचान लेना है कि ये 0 है या 1 है, right? So now come to the point. Yes. So if you see that with 4 numbers, we can go from 0 to 15. But if we use 4th bit as MSB, we have numbers only 2, 1 down to 0 to explain the magnitudes. So let us see what happens. So this is the signed magnitude, not in 1's complement, 2's complement form. So if it is plus 7, we can put a 0 here to denote the 0, like it is positive, and then it is 1, 1, 1. 0, 1, 0, like that we will go, right? Because this number will be always denoting the sign, right? So we will go 0 to 7, right? Now, if it is minus 0, what we will do, we will put 1 and then remaining 3. This will 1 minus 0, 0 and minus 0. See, there is a game here. In signed magnitude, normal number, not 1's or 2's complement, signed magnitude number, we have 2 zeros. This is the MCQ question. 2 zeros, 0 and plus 0 and minus 0. Right? In exam, there are, we can say in signed magnitude, without 1's complement and without 2's complement form, we have 2 zeros. Right? So, and then you can say this is 0 to 7, 8 number, right? And this again 0 to 7, minus 7, 0, minus 0 to minus 7, right? So you can say what is the maximum range? Plus 7 to minus 7 is the maximum range of the numbers, right? So if it is 4 digit, if it is 4 digit, if it is 4 digit, then 2 raised to power 4 minus 1, minus 1 to minus 2 minus 2 raised to power 4 minus 1 minus 1. So 2 raised to power 4 1 minus 1 is 2 raised to power 3 minus 1 is 7, and 2 minus 2 raised to power 3 minus 1 is 2 7. So you can say this is the MCQ question, right? This is the MCQ question. You can say the range is 2 raised to power n minus 1 and minus 1. You can say like inverted also, because we move only from negative to positive. You can say minus 2n raised to power minus 1 to minus 2, 2n minus 1 to minus 1. This is the range of signed magnitude numbers. But if we go in one's complement form, what is this? For positive number is the same. For 2's complement, everything is same. 0 to 8, 0 to 7. But if we see, we have discussed that one's complement of this is invert of them, inverted. But if we see that for 2's complement, the rule is we add 1 in it. So 4 bit, 134 plus 1, 0, 0, 0, 0, and 1 is created for 5th bit. So this is 5-bit number outside. Now you can see that MSB is 5. MSB is 5, right? Not 4. MSB is 5, not 4, right? So this is the game here, right? So what we do here, now you take simply in the inverters of that, right? Simply the invert of that, right? Correct. So we go like representation is invert of that, but here also we go from minus 0 to minus 7. Here also we have two zeros. This is 0, this is 0. But here, due to this overflow, because it becomes 5 when we add, like, what is the formula of 2's complement? Invert it and add 1. When we invert this and add 1, it becomes 5th bit, 5-bit number, right? Correct. That's why what we can do, we can simply remove it from minus 0. Minus 0 don't exist. So this is again a MCQ question. Minus 0 don't exist. Write down in your notebook in 2's complement, right? So what we see, minus 1 to minus 7 is normal, but due to this overflow means bit increased, so it will go to the next digit. See, this one is overflow, yellow color, we will keep it minus 1, so the number comes is like minus 8 to 7. So what we will do, 2n minus 1, right? This minus 1 we remove it from here, right? We give it 2n minus 1 means 2 raised to power, if it is 4 bit, minus 4 minus 2 raised to power 3, then it is minus 8, right? Minus 8 to 7. This is the important points you have to remember, right? There are multiple MCQ questions. How many zeros in sign magnitude? 2 zeros. How many zeros in 1's complement? 2 zeros. How many zeros in 2's complement? Only 1. What is the range? Because this 0 is overflowing, we add this value to the last, because it is going to 5th one. So we increase the, we have to, because something is going in the next bit, so its magnitude should be high. So what we do, we call it 8. We call it 8. As we call it as a 8, right? So this is the funda of making it the 8, right? So this is the end of the class, right? In the next sessions, I will explain binary divisions, and I will explain the computer method in later classes. Because as I understand that you people are not aware of the AND gate, OR gate, NOT gate, and these gates, multiplexers, and these things, recorders, and these things. So I will take later, because that thing will need the basic requirement of that. And please like and subscribe. If you people find that you need some urgent video on any topic, please comment on the comment box. I will create the video. Point 2, if you people find any doubts, please write in the comments. I will create a subsidiary video to explain the doubts. Thank you very much.